Okay guys, so today I want to show you Microsoft Azure Confidential Ledger, and we're going to use the client library for Python to step through it. We'll install the ledger and then try some code for some basic tasks where we're going to put some entries into the ledger. So if you don't know what confidential ledger is, it's, think blockchain. That's essentially what it is. It's a secure service for managing sensitive data records. So it's a permissioned blockchain model, and it offers immutability. So you can append only, right? That's a key difference between like a SQL Server database. So the ledger is append only. There's your immutability, and that's the blockchain model, and it's tamper-proof. All records are kept intact. Once you set a record, you can't modify it. You can't insert, overwrite, you can't upsert, you can't change anything. It's just a blockchain. So the first thing we want to do is create it. So what I've done actually in the portal already is I've created a resource group to be able to create it. Just called it my resource group over here. And here's the code that we're going to step through to set it up. So you have to install the Azure Active Directory Identity Client Library, and then install the Confidential Ledger Control Plane Client Library, and then the Data Plane Client Library with pip installs. I've already done that, but I can just show you those commands if you want to know them. It's pip install Azure Identity, and you can see I've already got it satisfied, and it's pip install Azure Management Confidential Ledger. And that's the control plane client library. And then pip install Azure Confidential Ledger is the data plane client library. So I've got all those packages installed. You have to do that before you get started here. So, and I've already created the resource group in East US. And I've already registered the namespace and all that kind of stuff. So we're ready to just dive into the Python. So you have to import the packages, and that's what these are up here. So lines 1 through 13 apply to what we just did with the pip install. So we're importing all of that stuff. Then we have to authenticate the application. That's line 15. And we're using the default Azure credential class to authenticate. So we've got the resource group set, and then we've got a name of a ledger that we want to set. So I gave it my name, and then I gave the subscription ID for my account. And then after that, we have to assemble URLs. So these are coming. If you go, we'll see that in the portal. But if you set an identity URL and a ledger URL. So we're just assembling that here, and then basically we're creating that control plane client. We pass in the confidential ledger API, the credential variable, and the Azure subscription ID. So we set that stuff above, and then we set some properties here. It's a dictionary, so it has key values, and then we assign that to a variable called properties. So this is a public ledger. You can have private ones, and it's in East US. And I've got these Azure Active Directory-based security principles is what I'm working with. And then this line 39 is how you create it. And I've commented everything after it because we're going to only create it once. So, and then I'll show you the code to enter records into the confidential ledger after that. But so this sets it up. This instantiates it. So let's just go ahead and run it. So again, confirm that we have nothing in the console. We'll refresh this page. We do not have a resource in the resource group. So I'm going to create a resource with what we just stepped through. So we're just going to run this code and wait for it to come back. So it came back down here. So we're done creating it. So I'm going to go ahead and comment this out and save this, and then I'm going to uncomment everything that comes after so we can step through that. And we'll step through it while we're waiting for it to create, because it takes a few minutes to create. So I'm going to selection, sorry, I'm going to edit toggle line comment to uncomment this stuff and then save this. So let's just go to the portal and see what the status is. If we refresh, we should see that it's getting created. Yeah, there it is, but it's not ready yet. So because I don't have an identity service endpoint yet and I don't have a ledger endpoint yet. So if I go to activity log, I would see that it's still creating. So we'll step through how we can add a record here. And we'll come back to the portal and verify that it was successfully created after that. So we're going to use the data plane client library. So again, going back to this code, once we have that ledger, we're going to interact with it using the data plane client library, which is that Azure.confidential ledger. So we have to generate and save a ledger certificate. And that's what we're doing in this block here. We're generating and saving a confidential ledger certificate. And then we're going to use that certificate down here. So we use that network certificate and the ledger URL and the credentials, and that's how we create a confidential ledger client. So that's that step. And now we're ready to write to the ledger once it's up. And I actually put a polar on here too. So this is how you would write something. So I just wrote hello world, and we're going to use the create ledger entry function. And then once we, what we're going to do is get the result and print it out. We're going to actually print the latest entry in the every time we run this, we want to see the latest entry down here. So that's what this code is. So the print function returns the transaction ID of the write to the ledger, which can be used to retrieve the message. We'll also look at it in the portal. The hello world is the message in the ledger that corresponds to the transaction ID that we'll see here in just a little bit once it's up. So, but you can't just write to the ledger and then immediately start retrieving things about it. You have to wait. So you have to have a polar in there if you want to wait for your write transaction to be committed to the ledger, because there's things it has to do. And if you retrieve it too quickly, it won't be ready. So I've got this polar here set up to essentially wait until the entry is durably committed. Remember, this is immutable, and durability is key here. So we need to wait until it's durably committed. So let's go back over to the portal here and refresh it and see if we're ready. We're still not ready, so we'll give it another minute or so, and then we'll come back here and make sure we've got these endpoints, and then we know we're probably ready to go. So we'll check back here in just a second. Okay, so we've got an identity service endpoint, we've got a ledger endpoint, and it's public, so we're ready to go. So let's go to the Explorer and show that we don't have any data here yet. We do not have any immutable, durable, committed objects yet. But we could filter if we had a lot here by subledgers and start at certain transactions and things like this. But this is a nice portal way of looking at your data if you need to do that. So that's what we're going to take a look at after we commit some data. So let's go back over to code and start committing some data. So in this, I'm doing everything in this one app.py. So I commented out line 39 because we already created the resource. But I am going to run everything again in order to establish this certificate. So we're going to open it writable as a cert file, and we're going to write it and then use those endpoints that were just created. And then we're going to write hello world. And we're going to set up that polar, get the result, and then get the latest entry from the ledger and print it. So let's go ahead and save this and run it. Okay, so there it is. Current entry, transaction ID 2.29 and collection subledger O, and here's the contents. Subledger :0, contents is hello world. So let's go over to the portal and take a look at that. So this is the Ledger Explorer preview. Refresh that, and we see that transaction ID. Now the interesting thing is when you click on it, you get the JSON representation details of the ledger entry, but you want the proof. This is blockchain right here. When you click on proof, you get all the information that you're looking for. So think of Bitcoin. If you wanted to look at the blockchain for that, you could get this kind of information. It's not exactly the same, but like the Merkle root, that's a blockchain concept. So you have these leaf elements where you calculate the value of the root, and if the calculated root matches the value signed by the ledger in the signature field, then the entry has not been tampered with. That's the thing. That's the great thing about blockchain. You know that entries are not tampered with, because if there's not a match, something's wrong. But if there is a match, nothing is wrong. You can guarantee that the data is accurate. So you calculate these digests. These are probably just SHA-256 kind of things. Evidence of a commit, this claims digest. So it says here, the transaction digest is a digest of the concatenation of the write set digest and the commit evidence digest and the claims digest to produce a leaf. And the leaf digest is verified with other receipts to perform an audit of portions of the ledger. So if you need to audit, this does do the audit. So you can get more information about that if you want. And then this is everything rolled up into one transaction receipt. So the transaction is globally completed, and we've got a write receipt that is issued because it was successful. So performing this receipt verification process proves the entry is immutable and recorded in this position in the ledger. That's very important for blockchain. These are blockchain concepts. So everything is good. We've got this transaction ID. Now I could write the same thing again, because remember, I'm not changing what's there. I'm just writing another entry by rerunning this again. And I should get a new transaction ID. And I do. I get 2.31, same contents. So now if I go back to the Explorer and refresh it, I should see another entry there. And I do. This 2.31 is the new one. And it has the same contents except for this transaction ID. And the proof is different. But everything proves out. It was successful. It's immutable. It's durable. It's verified. It's globally committed. And all these digests prove it. So I can't go in here and delete stuff. That's not how blockchain works. So if you're a SQL person or just a database person and you're thinking you can make changes or delete, that's not how blockchain works. So, but this is a great way to, if you want to back transactions at your company in a blockchain fashion, but you don't really want to use Ethereum and these kinds of other blockchain tools. Something like Confidential Ledger in Azure is a great way to get started. So I hope this helped you. This was just coming from the Quick Start Python at the learn.microsoft.com site, but I thought it was a great way to get started with Azure Confidential Ledger. Thanks for watching.